This will be an example of the extended PPGFeat app in use. The first thing we will need to do is to input all the data for the dataset we will be using. So in this case I know that the sampling frequency is 500 Hz, and if you wanted to resample it to another frequency, we would just select this option and select the final frequency here, but in this case I'm fine with 500 Hz. These values are for changing the values of the low pass and high pass parts of the filter, but I'll just keep those the same. I know that the entries in this dataset are very long, so to be able to see them easier, I will be segmenting these into, let's say, 5-second long segments. And the data in this dataset is also inverted, so I will select this to have it in the correct orientation, or well, negate the data. So then you can either choose to load a single file with the data or to load all the files in a one folder. So in this case I want to have multiple files. I'll be selecting this folder, which I can show here has full of data in CSV files. So I select this, and then the app will ask which files in the folder it should look for. So in this case CSV files. And then it will, in the case that there are multiple channels in the data, it will ask which one has the data we want to look at. And these 6 are different PPG channels, and so I'll just select PLEF1 in this case. So here we see it has loaded this is the raw data of the first entry, so that's quite a lot of samples. So here's the filtered first segment, which is 5 seconds long. So it has tried to, it might not be the best quality, this segment, but it has tried to find the best cycle, which is set the start here and end here. So we can either press plot to calculate the fiducial values for this cycle, or if we want to change it, we can edit the values here. So let's, for example, change this to here. Then if we plot, we can see it changed min2 to there. So now it has calculated the derivatives for the cycle and tried to find all the fiducial points. It has also calculated, using these fiducial points, all of the extra features based on them. So now we can either continue on to the next segment by pressing next, or we can manually edit these values if something looks wrong. Like, for example, I change x here to 80, and then we'll need to press the update button, which will change where it's placed. And this will also recalculate all the features based on the fiducial points. So then we can just go next, plot again, go next, plot, do that. But that will take quite a lot of time because of all the segments we have. So to do this a bit quicker, we can use the process every entry button, which will automatically go through every entry and extract the fiducial points and calculate the extra features. So now we have gone through all of the segments. This one cuts off because it's not a clean 5 seconds. You couldn't segment this entry into 5-second segments. But yes, it has now calculated fiducial points for every segment it could. So now we can choose to generate output either as a single .mat file or 3 different .csv files. So now we can save it as a .mat file in this case. Just save that here. And we can look at this, just take a look at how it looks here. So if I open this here, we have 3 different tables here. So info table is just information about general information about each cycle. So it shows entry, segment ID, where the cycle is, and the values from the signal quality assessment, both for the specific cycle and for the whole segment. The fiducial table shows all the magnitudes and time values for every fiducial point it calculated. And the feature table has everything in one table, both the fiducial points and all of the extra features. So if you extracted the data as a CSV files, these would each be a single CSV file each.